Algebra is like English. Terms are like words in a sentence, expressions are like phrases, and equations are like sentences. In the same way that a sentence is made up of words, a mathematical sentence is made up of terms. A term is a single constant or variable, or it could be a constant and a variable multiplied together. An expression, on the other hand, is a collection of terms. Now, what are variables and constants? Well, think about it this way. If you've ever been to a fun park like Aquasol or Duns River Falls or Mystic Mountain, then you usually pay an entrance fee, like $1,000, and then you may spend money on food. One day you might spend $300, another day you might spend $500, or sometimes when you go you don't spend any money at all. Now we could say that the money spent on food is a variable. It represents different values. It varies each time. Now, if I were to do some math with my money, instead of rewriting money spent on food each time, money spent on food, and saying it all again and again and again, I could use a symbol to represent it, probably the letter F or the food emoji. So that's what the symbols in math mean. They're not some random letters that are thrown into it, but they are variables that represent something. Now, our entrance fee that we mentioned earlier, $1,000 to enter, is what we would call our constant, a fixed or constant value. In the same way that I'd always have to pay $1,000 to enter that park, a constant always stays the same. Now, if we're talking about terms and variables, then we can't leave without talking about like and unlike terms. It's a very important idea, and I've seen a lot of students struggle further down in algebra because they may not have clearly understood the difference between these things in the beginning. So we have to spend some time ensuring that we get it right. Now, like terms are those whose variables are the same. So if I were to put a little table here of like and unlike terms, and if I were to just head it up right here on the two columns, then I could put x and 2x as like terms. I could put them under this column. Why? Because x and 2x are both x terms. They both have the same variable. Likewise, I could put something like p and p over 4 here, because both of them are p terms. Even though they have different numbers in them, they are still the same variables. On the other hand, I would have to put x and y as unlike terms, because obviously these are two different variables. Neither is x and x squared like terms. X and x squared are unlike. Why? Well, even though both of them have x in them, the power is different, and so on their own they would have different values. Here's a question for you. Would you say that capital A and common A are like terms? Well, I can see why you might think that, right? Because both of them are A's. But remember, we could use capital A to represent something else from common A. So we would have to put them as unlike terms. Now, the reason why we're even thinking about like and unlike terms is that we can use them to our benefit. We can add and subtract like terms to simplify expressions. So we can reduce expressions from 3 terms to even 2 terms, or even 1 term, or even to no terms, because we can combine like terms. Let's get an idea here in this example, okay? In this question, I want to simplify these two expressions. The first is 3x plus y minus 4x plus 2x squared. So first, I have to identify my like terms, which here I realize that I have a 3x, okay? 3x is not like y, but 3x is like 4x, all right? So I could put 3x and negative 4x as the two like terms. So 3x, negative 4x are like terms. None of them are like 2x squared, because as we said earlier, the power is different, so the terms wouldn't be alike. And no other term is like y, so I would have to just put back y. And no other term is like 2x squared. So again, I'd have to just put back 2x squared. Now that I have that, I can combine my like terms, because 3x minus 4x is just like saying I have 3 and I owe 4. So now I would have negative x, right? Negative 1x. Again, I can't combine any other terms with y, so I'd have to write back the plus y. And neither for 2x squared, so I just write back the 2x squared. I can't do anything more here, so simplified, it would be negative x plus y plus 2x squared. Now look in your second problem. Do you see any like terms here? It might probably jump out at you that negative 5x and negative x are like terms, okay? Because both of them are x terms, so we could group them together. But how about 6xy and 3yx? Well, if you think about it, right? You're comparing the terms xy and yx. Really, x times y, this is saying x times y, and this is saying y times x, and we know that both of these are the same. So xy and yx are like terms because they both have x and y in them. So these two are like terms as well. So that means we could write 6xy, we could group them together, plus 3yx, and then we could group together negative 5x and negative x. If we simplify, 6xy and 3yx would be the same as 9xy, because we would have 9xy's in total. And negative 5x minus x would be negative 6x.